Okay guys, welcome back. Now we are just moving to some exciting, I should say, part of our Bayesian analysis concerning the impacts of the Alzheimer and other factors on the brain atrophy after the age of 60. Remember that based on the things that we talked about that on the previous session, we learned that the brain atrophy based on the scientific literatures and the scientific experiments shows that the healthy brain is going to be different from the person who just suffers from the Alzheimer's disease. And also, with that respect, when we work with our data sets, we notice that when we just use the NLME package with the grouped data sets, we notice that if we just model the normalized whole brain volume with respect to the age, we had three levels in our analysis. We had group 1, which we categorized that for the ones which they had converted. Group number 2, which they had, I should say, dementia, and also group number 3, which showed the samples they do not have any sorts or any stage of Alzheimer's disease. And you can see that in any of those groups or any of those levels within the group that we had, we can see a different slope and the different patterns of, I should say, the normalized whole brain volume with respect to the age. And that's the reason that it motivates us to just go to the next step in our hierarchical model analysis within the Bayesian framework to see that how can we just talk about the normalized whole brain volume with respect, I should say, to the changes of the age from 60 to 90. Okay, in order to just answer that question, we are just going to come here, first of all, in our R, and that's the thing we are just going to do. We are just going to see how many levels do we have in our group, features of our data sets. Then after we define the data which is going to be suitable as an input for our stand model, then we just open a stand file to just write the different blocks which is necessary for running this model. However, I have to warn you that we have one more block which needs to be added to our conventional models block that we had before. Now, if you remember, when we talked about the data, we talked about, I should say, the group. It's one of the features that we had. It was a group once. And we just categorized the group session in the fact that number 1 shows that the samples they were converted. Number 2 represent that the samples they have the dementia or Alzheimer. And number 2 represents those samples or those observations that they are healthy samples and they do not have any sorts of dementia or Alzheimer. Then as a result, if we just want to see that, how many levels do we have, we can also check that with this, I should say, very basic formula, which shows that the number of the levels, as it's called n levels of the data, the group, it shows that here it's going to be 3. And that's also what we knew before, that we have 3 levels within the group: converted, demented, and non-demented. Okay, and that's the thing. And also, visually, we saw that there is variation within each levels of the group, which differs from the other levels. And that's very important to grasp and feel the meaning of it before we just move on. However, in order to just move on with the stand file, I'm just going to create a type of the data which is going to be irrelevant and the suitable inputs for our stand model, which has to become as a kind of a list type of data. I'm just going to call that data stand. Because I'm just working with the model B, I'm just call that model B. Okay. In the model B, you know that the data should just form a list. In our list, you saw before, we have some items. Number 1, it's not going to be changed from the things that we had before. It's going to be the n, which is going to be, I should say, the number of the observation of the data sets, which is 373, or essentially we can just put that as n row of the data. It's going to be essentially the number of the observation. The other thing that we had, it's going to be as what we had before. We have normalized whole brain volume. As we defined it before, it's the data which is going to be extracted from it, I should say the normalized whole brain. I put the comma, I go to the next line, and I'm just going to define the age, which it was essentially my single predictive variable for my data analysis, which it's going to be essentially age is to be extracted from, I should say, the data sets. However, I'm just going to add two more inputs and two more, I should say, objects into our list, which is going to be unique for this level of hierarchical model. The first one, I'm just going to define it something which defines the number of the levels within the group, which the pattern is different from one group, one level to the other one. You saw that the number of the levels, we just got that before. It can be defined as n levels, data, which I'm just going to extract, I should say, the group from it. But however, I'm just going to assign an object to that because we are talking about the group. I'm just going to check that with the letter G, capital G, which stands as the initial for the group. However, for any observation that we are just going to have from that group, for example, imagine that we are just going to take one observation. For example, the participants number, let's say 17 out of 373, we have to assign whether that observation belongs to level 1 or level 2 or level 3. So far, based on the n levels, we know that the maximum levels, maximum changing levels within the group, but however, for each observation inside the whole population, we have to give them a kind of an ID that, for example, observation number 17, for example, Mr. John Smith belongs to what level. And that's the thing which we are just going to do. In order to do that, I'm just going to call another the command. I'm just going to call that as integer. And again, I'm just going to extract the group from, I should say, from the data. However, I'm just going to call that again as group itself. For example, the group, when you call it as an integer, it works as, and I should say, as an index for any observation which is in our population. And essentially, that's all that we need by adding one level of hierarchy into our previous Bayesian analysis. These two ones, which is G and group, is two new objects that is added after we add one level hierarchy into our model. Okay, I'm just gonna execute that line by pressing Ctrl Enter, and you see that the data stand model B is created, which type is a list. And the other thing which we have to do now is that I'm just gonna go on to create, I should say, a stand file in order to just move on and create our different blocks that we expect to have. I'm just going to open a new file. I'm just going to have it as a text file, and I know that I have to just save as it as a stand file. I'm just going to go ahead. I'm just going to go to save as it. When I'm just going to save as it, I'm just going to go ahead in the folder which I have created these ones and call it as, for example, model BAD, which stands for the Alzheimer .stand. As I said before, the stand.stand is crucial because the file is recognized when you have it as .stand. You can call it anything you want, but you have to make sure that the .stand, the file is going to be named as that. Okay, we have some conventional blocks. Which one is going to be the data? The other one is going to be the parameters. Parameters, I should say, block. And also, at this stage, we have one other blocks, which we have to include that it's going to be transformed. Parameters, that's the thing that we didn't have that in our previous model, non-hierarchical model, we didn't have that one. And also, we have a block for the model. And lastly, we are just going to have another block, which I'm just going to call that as generated quantities, which is going to be, if you remember, it's going to be a block which is going to store the information as a memory for the replicated observation, depending on the model that we are just going to define on its previous block. Before we finish this tutorial, I'm just going to fill out the data block. Then on the next tutorials, we fill out the rest of the blocks as we have created. The thing which you remember from the previous course and the previous tutorials that we had here, you remember that the data block should essentially reflect and correspond on a one-to-one basis all the things that you have created as a list for your data, for your stand model. The first object which I have, it's called n. Then that's the thing which I'm going to do. I'm just going to put the n. I'm going to put the semicolon, and I'm just going to define the description of what signifies here. It's going to be the number of observation. It's about the n. And I know that I'm just going to put the integer because it's an integer and a lower one is going to be 0. It means that we can have 0 observation goes all the way to anything that we add to the model. I just go back to the list which I have created. I see that I have another object which is called nwbv. I'm just going to come here and create that. I have nwbv. That's another object. I'm just going to put the semicolon. I know that this one is the response variable. I know that also I'm just going to define a vector for that, and I'm going to define the length of the vector, which is going to be essentially the number of the observation. And that's how I define this one in a stand. And also the other thing which I have is going to be essentially the variable of the age. As an object, I have defined the age. Now I'm just going to do the same thing with the same spelling here. A semicolon. This one is going to be the predictor variable. For our predictor variable, I'm just going to define the age, and I'm just going to define a vector also, which it comes with the length of n as a number of the observation. As you know from the basic math, any vectors should be defined by a length. And the length of our vectors as both the response variable and the predictor variables is the number of the observation. Nothing more, nothing less. Also, in our list, I have two other objects. One of them is g. I'm just going to define it as g. I put the semicolon. I know that that's the number of the levels. Let's call that changing levels within group. And also I know that the g is going to be an integer because it can either 1, 2, 3 or anything. And also as an integer it can have a lower level of 0. And also the other thing which is going to be crucial for this part is going to be the group, which is a kind of an ID for any observation in our population. In order to just work with that, I'm just going to go to the next line, and I'm just going to just write group with no difference at all with whatever I have defined it there. And I'm just going to put as an index, that's going to be the ID for any observation indicating the level that it belongs to. Okay. However, for the group, I know that the length that I'm just going to define for the group, I'm just going to call that as something which is going to be the n, and that's the trick which we have to know. And also the index that we are just going to define, or the ID that we are just going to define for any observation of population, it defines an integer. The integer comes with a lower number of 0, or because we have just from level 1 to level 3, either it can belong to group number to the level number 1, or the upper one, it's going to be belonging to the group number 3. And that's how I define it. And that's very crucial because that's one in terms of, I should say, the data block. When we have multi-level analysis, it's very crucial then the ID comes with the lower as 1 and the upper as 3. That's the maximum of the levels, changing levels within, I should say, within the observations that we have. And I just go back to the list, and it seems that we have one-to-one correspondence by whatever I have defined as a list for my stand model, and also the one which I have defined as a data block for the same model. Okay, as long as we are here, make sure that you do not forget to save your model. And when we just come back on the next tutorials, we're just going to fill out the parameters and the rest of the blocks that we have in our model. Okay, then I hope to see you on the next tutorial, and see you next time.